Going to try another one of these. This time around, it's problem 57 out of chapter 1. And I'm doing this one because a couple of students in my classes have asked about this one. This one is one of these that looks more intimidating than it really is, but it's, read through the text of it. There's quite a bit going on. It's a fairly long looking problem. So here's the text of it. Read through the thing for a moment. Now, as always, the proper response to something like this is to go, ugh, but to not despair, because this is the Harvard of the South and we do not run from challenges like this. So we look through this thing and, as always, look for what it wants us to calculate. And ultimately, what it wants is dollars. Okay? It wants how much is this thing going to cost to put all this gold leaf, this extraordinarily thin bits of gold, over a certain area. So when we're all said and done, we're going to end up with a number, and that number will be dollars. So that's where we're going with all this. And then, as always, we read through the text of the problem to try to extract out whatever other bits of information there are in there. And as there usually are, there's actually quite a few conversion factors in there. We're told things like a troy ounce, I was going to abbreviate it TOZ, troy ounce for reasons, I don't know, that's the standard they use for gold. 1 troy ounce is 31.1 grams. That's one of the conversion factors given in this particular problem. We are told the density. This one is one of them that has a density that I'm going to treat as just another conversion factor, the density of gold. And you're told the density of gold is 19.32 grams per cubic centimeter, which is, of course, another way of saying that that number of grams and that number of cubic centimeters for gold are the same thing. You are also told that 1 troy ounce of this stuff of gold is $54. Okay, that's the information given to us in this particular problem. Now, that's kind of mining out of the problem what they want us to figure out or to get. And then there's some other information about the size of this. And again, they're talking about gold leaf, extremely thin bits of gold that you can use to cover things like a ceiling or a wall or artwork of some sort. And it's like many of these, it's sometimes a good idea to have a picture of it. So I'm going to draw a rough approximation of this gold leaf with no attempt at being artistic whatsoever, except I'm trying to draw it three-dimensionally. Okay, try to give a feel that this is a three-dimensional object that may be 100 feet long, 82 feet wide. But the thickness, while there, is extremely small. And in fact, for this one, they say in words 5/millionths of an inch thick. I'm going to write that down. That's how they phrase it in the problem. Now, in order to interpret 5/millionths of an inch, that's not much, real small. But remember, tenths, hundreds, thousandths, 10,000ths, 100,000ths, millionths, 5/millionths of an inch, or 5 times 10 to the 1, 2, 3, 4, 5, 6 to the -6 inches. There's the thickness, 5 times 10 to the -6 inches. There are your volume information. You realize that's a volume. Length times width times height. length, width, height. Now, once you see that, then suddenly this problem becomes, I think, fairly manageable. Volumes, densities, the magic conversion between the world of volumes and masses. The rest of the information, masses and dollars. Once we get this volume turned into cubic centimeters, we're then one step away from a mass in grams, which is one step away from mass in troy ounces, which is one step away from the actual cost. And so this particular problem, though it has a lot of wordy parts to it here, really is turn this into cubic centimeters and then into grams, troy ounces, dollars. Once again, it makes use of all this volume type stuff. The other interpretation, as we've seen many times, of volume is area times height. And in fact, that's the one I'm going to make use of. Because clearly I have the information for the area, how much of a rectangle this stuff makes, and then I'm going to multiply it by height. I will have to make some modifications in there, but we'll get to those in just a moment. So, first, the area is simply 100 feet by 82 feet, or 8,200 square feet. Okay, pretty straightforward there. The volume of this thing is nothing more than the area, 8,200 square feet, times the height. Now I am going to write it in just a moment. And realize, as I do that, I do have a crisis. My units, oh, that's square feet. My units do not match up. And so I cannot quite do this until I have them all converted either into inches or into feet. Inches is going to be the easier one because inches is simply one step away from centimeters. So that's the one I'm going to do. I'm going to turn this 8,200 square feet into square inches. I'll do that one over here. 8,200 square feet. Feet, go away. Turn them into inches. It is 12 inches is 1 foot. Now, that is going to come out square feet. So I better square the entire conversion factor. That will give me square inches. And that will come out 1.1808 times 10 to the 6 square inches. Okay? 1.1808 times 10 to the 6 square inches times 5 times 10 to the negative 6 inches. Square inches, inches. Yes, I am going to come out with cubic inches, a volume unit, kind of how it ought to work. And the value is 5.904 inches cubed. Okay? Now, once I'm in inches, cubic inches, I am one step from cubic centimeters, and then this thing is really off to the races. So here I go. 5.904 cubic inches. Inches to centimeters. We are pretty familiar with that conversion by now. 2.54 centimeters is 1 inch. Oh my, I have 3 inches, cubic inches going in. I'm going to need cubic inches coming out. Cube to cube, better cube the entire conversion factor. Cubic inches. I worked hard to get there, now I'm going to kill them off. Cubic inches into grams. Now this one, 19.32 grams is 1 cubic inch. This cubic unit to normal old grams, a density conversion factor. This conversion factor, left alone. Cube to cube, cube the whole thing. Cube to plane unit, leave it alone. Now I've got grams. Not the unit of my answer, but boy is it close. Grams, I can turn grams into troy ounces. Yeah, I'm told 1 gram is 31.1, or 1 troy ounce is 31.1 grams. And finally, 1 troy ounce is worth $1,654 in gold. And if I now punch all that out on my calculator, 5.904 times 2.54 cubed times 19.32 divided by 31.1 times 1654. When I did that, my magic calculator gave me back $99,410. It's going to cost almost $100,000 to do this. Now, one thing you see when you look up the problem in the back of the text, because this one does have the answer back there. The answer that they give is not $99,000. And in fact, it's closer to $60,000, 6 times 10 to the 4th. What they are doing in the error they made, in the 12th edition of our textbook, in 12th edition Brown-LeMay, the price of gold was very different. The price of gold in the 12th edition was $953 for a troy ounce. And that changed the calculation. In fact, you plug this in to this calculation, that's where their answer comes from. Why the 12th edition answer carried over to the 13th edition when they did update the price of gold, which varies every single day. It goes up, it goes down. It's one of these things that, never very steady. I have no idea. But that's the reason why when you look up the answer in the back of the text, you probably won't get what they have printed because they made an error. They used this 12th edition number when they printed the 13th edition answer. But there is the answer, nearly $100,000 to put the gold leaf on the ceiling or in this area here given in this problem using that price expressed in the problem. So there it is. Not a terribly difficult problem. Again, I think we read it, looked where we needed to go, extracted out our conversion factors, knew a few others, inches and feet, either by looking them up or having previous knowledge, but also we analyzed by drawing a little bit of a picture. It's not a very pretty picture, I admit, but it's a nice picture that works. Definition of volumes. How many times have we seen that? And now with a density as one of the conversion factors given in this problem. There's the solution to it. Go forth, have fun with it, and calculate. See you later.